Hello class, welcome to this video on the AP Stats 4.3, 4.4 prac homework. This is chapter 4, lesson 1, essentially part 3 and part 4. So let's go ahead and get started. So in 4142, we looked at simple random samples, simple random sampling, and we looked at stratified, but now we're going to look at cluster sampling systematic. So name one way that a cluster sample is the same as a stratified random sample. All right, so we want it to be the same. So for one, in both types of samples, you had to split the population into groups, right? In one example, you split it, you split them by location or proximity to each other, and in the other, we split them based off of some kind of characteristic that is similar within those groups. Okay, so one way that is similar is that the population is split into groups. Okay, so the population is split into groups. And in the case of the cluster sample is split into clusters, and then stratified split into strata. Name one way that a cluster sample is different from a stratified random sample. Now we're going to go ahead and explain the difference here, the cluster. So for a cluster sample, the group has individuals that are different. So cluster samples have groups that are heterogeneous and because cluster samples are based the population is split into groups based off of location. This means that there's a good chance that the groups are generally heterogeneous, that there's a mixture of different people. Whereas for a stratified random sample, the idea is to make the groups the same, right? So the groups have, between the groups, there's different characteristics, but within the groups, they're homogeneous. So they all have that same characteristic, and within that one group. Okay, so they have individual similar characteristics. So I'm going to also mention another thing here. This is one way, so we'll explain another way as well. So a cluster sample basically takes a simple random sample of groups, whereas and then selects everybody from that group. Whereas a stratified selects a simple random sample from each group. Okay. So cluster selects a simple random sample of groups collecting data from every individual in the selected groups. Whereas in stratified selects an SRS from each group. So it uses all the groups, but it selects randomly for each group. All right, so number 2. At a certain high school, every student is required to take an English class each year. English 9 for freshmen, 10 for sophomore, 11 for juniors, 12 for seniors. They're also required to take a physical education class each year. The high school counselor wants to use a cluster sample to estimate the proportion of students who have their driver's licenses. Should the counselor use the English class or the physical education class as the clusters, and then explain. So if the counselor uses the physical education class, then you'll have all the grade levels, right? So, So it says here that the physical education classes each year with multiple grade levels in each class. So this is the key here. Whereas in the English class, it's English 9 for freshmen, then sophomore, so they're individual. They should use the physical education classes because if we're doing a cluster, we want the population to be heterogeneous. Okay, so all right, so we're gonna say select physical education. In order to have groups that are heterogeneous with respect to grade level. Okay, so what is one advantage of using a cluster sample compared to a simple random sample? So there are certain situations where, doing a cluster, could have its advantages, right? So the reason why we tend to do cluster samples is that it's convenient, right? You can just it's easy to select a group of people that are in proximity to each other, right? And you can do this efficiently as well. So in this case, it said the data is collected more efficiently. So in other words, it's more convenient. It does, but remember, cluster sampling does have that element of randomness as well. So it just in this case, since it's based on proximity, it's more efficient. So the counselor will only need to go to a few selected rooms. So again, we still have to randomly select the rooms that we have, right? But at least when you go to that room, you could just sample every single student there, right? It's not like you have to go to every classroom and select some students, like a stratified sample. Or in a simple random sample, you would number everybody in the classes, right? And then you select a few that could be in different classes. All right, so the counselor only needs to go to a few rooms, a few selected rooms to interview all students in each room. Okay, so number 3. Each Major League Baseball team is allowed to have 26 players on their roster for opening day. With 30 teams, this means there are 780 players on the opening day rosters. An avid baseball fan wants to select a random sample of these players. Describe a method for selecting a simple random sample of 100 players. Okay, so we're going to, so it says, so first off, we want to label each player. There's 780, right? And let's use a random number generator. So label each player. From 1 to 780. Use a random number generator. To generate, we want 100 players, so 100 100 different numbers from 1 to 780. Again, they're different, so no repeats. Select each player. Corresponding to numbers generated. All right, so that's for a simple random sample. Now we're going to do a stratified, a sample of 90 players. Okay, so let's just say we take a stratified sample. Again, recall, is you're taking some players from each, or some people from each group, right? So you're using all the groups, but you're only selecting some of them. So since we want to since we want 90 players and there's 30 teams, right? Then that means we're going to want to select 3 person per team, right? For a total of 90. So we're going to, and each player and each team has 26 players. So what we're going to do is we're going to go to one team, label the players from 1 to 26, and then select 3 different numbers, right? Between 1 and 26. Let me, I forgot to put here, let me change this between 1 and 26. I put from 1 to 780. It should say between 1 and 780. So I just noticed that. Apologize. So between 1 and 780. All right. So then once you do 1 to between, so generate 3 different numbers between 1 and 26. Then you repeat this for each team, right? For all 30 teams. All right. So let's do it for one team. So for one team, label each player from 1 to 26. All right, use a random number generator. To generate 3 different numbers between 1 and 26. Again, no repeats. Select each player. Corresponding to numbers generated. Repeat this process for all 30 teams. Okay, so there you go. So now we're going to describe a method for that could be used to do a cluster sample of 78 players. So a cluster sample, you're randomly selecting some of the teams, right? And then you're selecting all the players from those teams. Okay, so how do we get 78 players? How many teams would we have to choose to get 78 players? Well, each team is 26 players. There's 30 teams, each with 26 players. And so that means we're going to have to randomly select 78 divided by 26 equals 3 teams. Okay, so we're going to need to randomly use a random number generator from 1 to 30. We're going to number the teams, right? Then we're going to pick the teams that we want. So we're going to randomly select 3 teams, right? Then we use all the players from each of those 3 teams, and that would be 78 players, right? Okay, so we're going to label each team. Let's see. Okay, label each team from, oops. 1 to 30. And I'm going to put here, I forgot to put here, and this is not necessarily a fatal flaw or anything like that, but I'm going to put label each player uniquely from 1 to 780. So I'm just going to put here unique. So label each team with from 1 to 30. Uniquely means they're all different, right? So it's not like you have 2 teams that are number 2. Label each team from 1 to 30 uniquely. Or you could say label each team with a unique number from 1 to 30. Then use a random number generator. To generate three numbers. So we want 3 teams, 3 different numbers, or 3 unique numbers, or 3 numbers, no repeats. Either one of those is fine. Between 1 and 30. Select every player from each team. I'm going to underline that part, from each team. And for each team, that corresponds to numbers generated. All right, there you go. So there's our cluster sample. So now I'll describe a method that could be used to select a systematic random sample of 78 players. All right, systematic. So systematic, again, is you randomly choose your starting point, and then you select every kth individual, where k could be a number, any number, right? Every 3rd individual, 4th, 5th, whatever. And then you keep doing that until you get your, however many you need. So we want 78 players according to this. So this means that we're gonna have to use all the players between all the teams. So there are a total of 780. I think that said 780. Let me double check. 780 players. Yeah, because there's 26 times 30. Okay. So 780 players in total. So we're going to have to number those players, right? From 1 to 780. Use a random number generator. Generate one number. We want... now, it doesn't really say... like which one, do you want to do the third one, fourth one, fifth one? You got to choose that. Now, one thing you could do is if this is your, to select your random starting point, your random starting point need not be anywhere in the group. It could be, for example, within the first 10 students or something like that. So for example, let's say there are 78 rows, right? Each with 10 players. Then you could, so in this case, it's going to be from 1 to 10, right? And then from 11 to 20, whatever. You could select a random player from the first row, right? So you could select a random player from 1 to 10. And let's say you selected this individual. And then you can go, and then you can do every 10th individual after that, right? So if I do player 9, then I can then choose player 19, then 29, and so on and so forth. And then I would, when I do this, I would get 78 players, right? So you could do that, right? And again, that would be one way to set it up. And you could get 78 players. Now, you don't have to do it this way. You can choose a random starting point anywhere and then do every whatever you want. And then keep doing this until you get 78 players, right? But this guarantees that you're able to get 78 different players with no problem, right? Okay, so label each player. This time I'm going to use the word unique, okay? Instead of using uniquely. With a unique number from 1 to 780. Use a random number generator. To generate one number between 1 and 10. So this is what I was saying. I was going to do the pick from between the first 10 to start with. I'm going to randomly choose one of those. The player that corresponds to this number is the first player selected. All right, so then that's the first player. Then you can do every 10th or whatever. So then select every 10th player past this player until 78 players are selected. Let me rewrite that. Until 78 players are selected. Okay. All right, so let's look at the next question. So this is a really good question to kind of show the difference, highlight the difference in the methods, right? And how to actually explain them. So this is why it's very important to have these, to have these exercises so that you can practice that. All right, so Zillow wants to estimate the average value for houses in Chicago, which has 178 official neighborhoods. To do this, they will select a random sample of houses in the city and send an inspector to each house to find its value. Option 1, select a random sample of 5 homes from each of the neighborhoods. Option 2, select a random sample of 5 neighborhoods and then visit every house in the selected neighborhoods. Name the sampling method used in option 1. Give 1 advantage. Okay, so option 1, you're selecting a random sample of 5 homes. In other words, each home is a group. Each neighborhood is a group, right? So you have a neighborhood, which would be a group, and then you have the homes within that, right? And so you're just randomly selecting 5 homes from each of the neighborhoods. So these are your groups, the neighborhoods, and then you're selecting 5 random ones from each. So then that would be a stratified sample. Stratified random sample. And this method guarantees that all neighborhoods will be represented. So that's the good thing, right? Okay, and then option 2, select a random sample of 5 neighborhoods and visit every house in the selected neighborhoods. So again, you're choosing, you're randomly choosing between the neighborhoods, right? And then once you choose them, then you do everybody in the neighborhood, right? For the ones that you selected. Okay, so this is a cluster sample. And since you're doing everybody in those selected neighborhoods, it makes it a little bit easier because it's not like you have to go to every single neighborhood, right? You only have to do the neighborhoods that you selected, and so it makes it more efficient. All right. Which method is more likely to produce better estimates for the true average house value in Chicago? So in this example, the best option is going to be option 1 because, as we said earlier, this guarantees that all neighborhoods will be represented. And so there's some neighborhoods that will have houses that may not be they may not be as expensive, right? And there might be neighborhoods that have really expensive houses, right? Depending on the area that they're located. And so if you reach out to all neighborhoods and randomly select certain houses from each neighborhood, then that will be a better representation of the city, of the average. Okay, so this one's the stratified random sample. Because some neighborhoods have more expensive homes. And this method ensures houses from all neighborhoods will be represented. Which should yield a better estimate. For the true average house value. Okay. Okay, which should yield a better estimate for the true average house value in Chicago. Okay, so let's look at the next one. So the Gallup organization conducts surveys to find out public opinion on a variety of current topics. They often use complex methods to select their samples. Suppose they're considering 4 different sampling methods for estimating the president's job approval rating. For each of the following sampling methods, create a dot plot which represents the estimates from 10 simulated samples. Suppose that the actual job approval rating is 45%. Okay, so this is a good problem for bias and variability. All right, so let's kind of review what we mean by bias variability. So bias means that you're off target, right? So that means you're over-representing or you're under-representing, or both, right? Now, if you have high bias, that means you're either consistently overestimating or you're consistently underestimating. Okay, and that's why you got high bias. Low bias means that you're close to being on target. You have either overestimates, a mixture of overestimates, underestimates. Well, okay, so so the idea with bias and variability is that if this is the target value and you have low bias, right? You can have low bias and high variability, and you can have low bias and low variability. So so let me kind of illustrate that before drawing the dot plot. All right, so let's say this is the target value, right? The true value. So then low bias and high variability would be when you have, okay, so low bias means that you're over and underestimating, right? Over and underestimating, or you could be on target, right? So there's times you can be on target, right? So there's, let's just say this is a dot plot or whatever. So here you have over and under and over estimates, right? And so that's going to be low bias because, it's not bias in one way or another, right? Bias means one-sided. Bias is one-sidedness. So, and then if you have low variability, then that means your data values are really close to the true average value. Now, if you have low bias and high variability, then you're going to low bias. So that means you're going to be, you're going to be on either side. But now you can be far away from either side. You don't have to be close to it, right? And so now we got some values that are spread out from each other. So there's high variability, right? High V. I'm going to say V for variability. But it's still low bias because there's no one-sidedness, right? And then high bias would be you got your target value, you got high bias, and so you may have some that are underestimates, but you have the majority that are overestimates, right? So that would be like high bias. And this would be high variability, high bias, but then you could have low variability, low bias, and so you can have these closer together. So hopefully that makes sense. So this would be high variability, high bias, low variability. So there's different variations, okay? So let's go ahead and draw the dot plots, and we need to make sure that when we do the dot plot that the average or the median of the dot plots is 45%. Okay, so there's multiple answers for this. There's not one answer. However, the answers have to follow certain principles, of course, right, of low bias and low variability. All right, so there's a lot of ways to do this answer, but as long as it makes sense. So let's do part A. over here. Okay, so let's do a dot plot that resembles this. Let's say, okay, so let's do, let's just do something like this. So 28. Yeah, let's just do the 50. Actually, let's do 52, 54. Let's do that. Okay, so clearly, since the true value is 45%, our median should be here, right, when we do the dot plot. So let's go ahead and do that. So let's do low bias, low variability. So there's some on either side, and then they're close together. So we could, for example, do maybe a couple of dots on there, and it says for the following samples, yeah. So it says 10 simulated samples. So we need 10 dots, right? Okay, so we need 10 dots. So let's say there's 1, 2, 3, 4 dots there. Well, then we could do something like this, where it's sort of symmetric, I guess. You could do that. So there's 10 dots there. The center of that is, oh, no, that's the center is 46. I need to move this closer, sorry. 1, 2, 3, 4. And then let's move this one a little closer. All right, so now the center of this for sure is 45, right? But it has low bias, right? And low variability. Okay, so there's an example of that. What I'm going to do is I'm going to copy this so that we can do the other ones. Here, let me do it over here. Okay, so that was part A. We'll do part B over here. Okay. So let's do part B. All right, so part B is low bias, high variability. So that means that these dots here can be spread out, okay? So, let's go ahead and spread those out. So we might have, for example, a couple of dots here, and then we would need the 4 dots. Wait, let's see, 1, 2, yeah, okay. So then if there's 2 dots here, where this is the center, in order for this to be the center, then we would have to have 4 dots kind of spread out, right, on either side. 4 plus 4 plus 2 is 8. So let's have these spread out, shall we? There's 4 dots there. Yeah, maybe something like that, okay? So that way the middle is 45, right? And there's high variability, low bias, because there's a good, I either underestimate or overestimate, or I'm on target. So that's low bias, but it's spread out, high variability. All right, so now let's do part C. So this is a good exercise to get you thinking about these two concepts and creating your own graph. So let's see, let's take this out. So next we want to do high bias and low variability. So it's got to be more one-sided now. All right, so let's say we estimated consistently. And let's do okay. And so now what we're gonna do is, so let's just review, right? So a low bias means we're pretty much on target, but we over and underestimate, and then we're sometimes on target, right? So we're on target, we over underestimate. It's, you know, we're pretty close to being on target, but we're over under representing it at times, right? Part B, we are still on the target, but we're like, our average is on target, essentially. If you think about it that way, our average is on target, but we're spread out, okay? If you think about it that way. Now this one, part C, our average is not on target. Our median is not on target. It's the median of the data is either over-representing it or under-representing it, okay? And so we need for our, so if this is the true value, right? Then our data is such that it's going either under or over it. So let's do something where they're close to each other, but they have low variability. Okay, that's 1, 2, 3, 4, 5, 6, 7, 8. Let's do, okay, let's do another one here and here. Okay, so that should be 10 dots, 2, 4, 6, 8, 10. So they're really close together. So low variability because the dots are close to each other. Low spread. So there's low spread. However, the average is off target. So so you can see I'm consistently underestimating the true value, and therefore I'm going to be consistently off target here. So here, let's say the average here, the average for me, let's see, 1, 2, 3, 4, 5. So it's between 5 and 6. So this is my average. Oops, I didn't mean to delete those. I don't know what happened there. I don't know why I deleted that. So this is my sample median. So you can see there's a bias, high bias. Okay, so bias is how far off target am I, and it has to do with consistently underestimating or consistently overestimating. Variability is how far am I shooting, or how far are the dots spread out from each other. Okay. All right. So let's do part D. So this time, let's, so let's do this. So now we're going to do high bias, high variability. Okay, now for this one, the true value is here, like we said, or 45. Let's say we underestimated. Let's say we're over here. And let's say there's high variability, right? So it's going to be spread out. All right. This is my sample median. Is right there because that's the halfway point of my graph, of my dot plot. 4 on either side, so that's the middle. That's the middle number. High bias, and high variability. Okay. Again, if you think about it as a target, and this is the bullseye, high bias, low variability would be akin to doing this. You're consistently off target, but your dots are close together. High bias, low variability, or high bias, high variability is you're off target, but your dots are like spread out, right? So that would be high bias, high variability. All right, and then obviously if you got low bias, high variability, well then you're on target, but then you also have spread out, right? You also have spread out. And then high bias, or low bias, low variability would be something like that. The dots are close together and they're pretty much averaging to be on target. Okay, so hopefully that makes sense. All right, so we're at number 6 now. So number 6, a small western town is split in two, divided in half by a river that runs through the middle of the town. And again, I think you may be able to skip this part of the video unless you want to learn a little bit more. This is not part of the homework that I gave you, but this is a couple extra problems. A small western town is split in two, divided in half by a river that runs through the middle of the town. The local chamber of commerce wants to survey residents about a proposal to shut down the fish hatchery on the outskirts of town. The chamber of commerce will select one side of town and survey every 5th house. Then the chamber will go to the other side of town and survey every 5th house. Which of the following is the best description of the type of sample the chamber will select? Okay, so again, try to choose an answer before I reveal the answer. But here we're selecting one side of town, surveying every 5th house. So that has to be a systematic random sample. High school hosts a freshman orientation day before school to introduce new students to the school. During the orientation, they're placed into groups of 8 freshmen, 2 seniors who act as leaders. Groups do activities throughout the day to get to know each other. Random sample of 3 groups was taken, and each individual in the group were surveyed. Which of the following statements about the sample of 30 is true? It's a systematic sample. No, it's not systematic. Stratified random sample. All students were selected from some of the groups. Stratified is when that's a cluster. That's not stratified. So that's wrong. It's a stratified sample because some of the students were selected from each group. No, it says all the students were selected from some groups, right? There was only 3 groups. And each person was selected from the group. So it's not that one. It's a cluster sample because all the students were surveyed from the randomly selected groups. Yeah, that's true. And then all. Okay, so the answer is D. All right, so we're at part 4 now. So let's take a look. So this one is about bias, like different types of bias. Bias occurs when certain responses are systematically favored over others. Name 2 poor sampling methods that could lead to bias. The 2 methods that we talked about in class, convenience and voluntary response. Name at least 2 other types of bias that can occur when collecting data. Again, convenience sampling, you're selecting those that are near you. Convenience, right? And then voluntary response, you have volunteers. So, so here, 2 other types of bias that can occur. So we could have undercoverage bias. That's when you're removing people from being covered by the poll or by the survey because of certain factors, like for example, a telephone landline. If you're doing a survey based on people that have landlines, then you're going to exclude those that don't have landlines, right? So yeah, undercoverage bias, non-response bias are you could reach, or let's say you're doing the landline ones. You could be able to reach the people that have landlines, but they hang up or they refuse to respond. So that's non-response. Response bias, for example, the landline survey. You could have people responding to the questions, but maybe they respond inaccurately. either because of the way you worded the question or whatever. And then, or, other things that could lead to response bias. They could lie in their responses and things like that, depending on what kind of the nature of the question. And then you have, you can have something called question wording bias. Okay, now question wording bias is a specific type of response bias. And it's basically what I mentioned earlier is if you have a survey or whatever, and you word it in such a way, like you word it so that it's a leading question, or you word it so that it's a double-barreled question or whatever. There's ways that you can word things to get a certain response, to elicit a certain response. All right, so Whole Foods is a supermarket town known for having natural and organic food, often at higher prices than other supermarkets. They recently surveyed a random sample of their customers. Based on the survey results, they claim that 70% of millennials are willing to pay more for high-quality foods. All right, so name the type of bias that was present in this survey. And then explain. All right, so, well, first off, I guess if they're going to Whole Foods, right, which is a very specific supermarket, which with a niche clientele, right? I guess if you're buying things at higher prices and having the natural and organic food, you're taking a random sample of their customers, then you're excluding people that don't go to Whole Foods and go to other supermarkets, right? So this is an example of undercoverage bias. And they're talking about, so as those who don't shop at Whole Foods are not included in the sample. All right, so do you think the 70% claim is true? Well, because of this bias, it's not going to be true, right? So no, and we want to explain it. So because if you're selecting people that are in the shop, then and it says you're looking at the 70% number, then obviously if you're selecting people from Whole Foods, then then obviously you're going to have more people that are willing to pay for high quality foods because you're selecting them from that supermarket, which is known to have higher prices and quality food, right? So it's likely that this is an overestimate. All right, so we'll say millennials at Whole Foods are more likely to pay more for high quality food. So this would be an overestimate. Of the true percent of millennials. Okay, so Gallup is an organization that collects and shares information about public opinion. Kentwood Public Schools partnered with Gallup to create a survey for teachers in the district. The survey was sent out through email to a random sample of 100 teachers, and with 56 teachers responding. One of the questions was, how much time do you have for planning each day? For the 56 teachers that responded, the average amount of time was 85 minutes. Does this scenario describe a voluntary response, non-response, or both? So this actually has, so this scenario has non-response bias. So because the reason being that you had 56 teachers responding, that means you have 44 did not, right? Because there was a total of 100. You reached out through email to a random sample of 100 teachers. Now, this is not voluntary because it's not like you're opening this up to the entire teacher population and then teachers get to respond, right? You're intentionally sending it to 100 teachers, okay, to respond. So again, voluntary response is it's open to the population. Then any person in the population of interest can respond. Here, you're specifically selecting 100 teachers, right? And so you're sending an email only to those 100 teachers. Now, could they respond or could they not respond? Yes, right? And there's the non-response bias that we're talking about. So you got non-response bias. Since 44 out of 100 teachers didn't respond. It's not it. So we're going to put it's not voluntary. It's not voluntary response because there was an intentional sample of 100 teachers, not an open invitation. To all teachers, and that's key there. So it's not voluntary because there's an intentional sample of 100 teachers, not an open invitation to all teachers. Now, do you think the average amount of time for planning is higher or lower? So we know that it's biased, right, because of the non-response bias. But do you think it's higher or lower than the true amount? Okay. So they said they had average amount of time was 85 minutes. Okay, so the idea is that, okay, well, if certain teachers are responding, then why are the other teachers not responding? Maybe because they don't have as much planning time, right? If the teachers that are not responding may not have time to even bother to respond to the survey because they have less planning time. It's possible. And it's also possible that those that did respond have more planning time, and that's why they're able to respond, right? So that's something to keep in mind. So therefore, it's likely that the average amount from the sample is higher than the true amount because we're excluding those who didn't respond, which may have had less time. And so therefore, we end up overestimating the true amount. So it's likely to be higher as teachers that didn't respond were more likely to have less planning time. In other words, they're more busy. Than those who had time to respond. Okay, all right. So it's important that you at least acknowledge that there may be a factor involved. So one of the administrators suggested a larger sample size. Would this reduce the bias? Now, larger sample size will not reduce the bias. The bias is in the method, not the sample, right? The bias is in the factors involved and not in the sample size, right? Bias would reduce the variability generally, but it will not reduce the bias, okay? So larger sample size reduce variability. They do not necessarily reduce bias, right? So So we're going to say no. While there will be more teachers that respond, there will still be teachers that don't respond. Which are going to be systematically different in some way, right? Leading to the same bias, resulting in the same bias, right? So again, large sample size reduce variability. However, just because you reduce variability does not mean that you reduce bias, as we evidence in the example that we did here, right? We could reduce the variability, right? This one is reduced variability. So before it might have been high variability, but then we reduced the variability, but it's still biased, right? So this would be, for example, if you had a lot of people, then you might see, okay, they might be closer together, but there's still that bias there inherently. Okay, so that's just an example. All right, so let's look at number 4. So a new ride-sharing company called Uber Lyft, with 2 O's, wants to survey their customers about their ride-share experience with the company. Using the app, they send the following request. Our users have consistently had very positive experiences with Uber Lyft. We will always continue to strive for perfect 5 stars review. What is your rating for your experience? Name 2 potential sources of bias in this survey. Okay, so first, there's definitely response bias, right? Now, let's distinguish a little bit response from question wording, because this one also has question wording. Question wording bias is in the wording of the question, right? Obviously, so it's in the wording of the question, and that will lead to bias. Also, if we talk about response bias, other factors, for example, users might lie. They might rate their experience higher than the truth, or the other way around, right? So, according to the wording of the question, there's response bias, in that the users might not rate their true experience because maybe they don't want to disappoint the company or whatever. I don't know. But then there's also in the wording. So let's go ahead and this is 2 potential sources. So we have question wording. Here, question wording. They added additional information. Users have consistently had very positive experiences with Uber Lyft. That is the question wording bias that I'm talking about, right? So includes additional info that is leading. That's called a leading question. You're leading with something before you start doing the question. All right, and then you got response bias. Okay, which this is more specifically response bias. We're talking about users potentially lying. So users potentially rate their experience higher than the truth. So for example, don't want to disappoint or whatever. I'm just going to put don't they don't want to disappoint, etc. Okay, so A middle school band teacher assigns students to practice their instruments at home for 15 minutes per day. Students are required to keep a practice log when they record the number of minutes they practice. The teacher selects a random sample of 10 practice logs and finds the average amount of practice per day is 17.8 minutes. Name one potential source of bias in this survey. Well, okay, so if the students are required to practice 15 minutes per day, and they record on their log, and they're expected to do 15 minutes per day, right? Then they might be self-reporting. They might be lying about their practice times because they're self-reporting, right? So they're saying, oh, this is what I got. This is how much time I practiced, right? So it might not be truthful. So response bias. Students are self-reporting their practice times, which may not be truthful. So again, this is a potential source of bias. Do you think the average amount of time practicing per day reported by students is higher or lower than the true amount? Well, they likely over-reported what their practice time, so this is likely to be an overestimate. So students might want to show they practiced a lot. For grades, etc., right? So they would report longer practice times. Than the actual amount. All right, see, identify a solution that the teacher could implement to resolve this bias. In order to, one way that you could do it is provide evidence that they did the practice, right? So for example, have the students record themselves practicing, right? So they require that the students record themselves practicing, like an audio or whatever, or a video to show, and then submit those, right? And then of course those recordings will have a timestamp and things like that, rather than just self-reporting. Okay, so teacher could require students to record themselves during their practice session. Instead of self-reporting logs. Okay. All right. So that is it for that assignment. So now if you want to practice these questions, make sure that you get them before I give the answer. It's multiple choice. So a company whose workplace went remote is considering requiring some employees to return to the office at least 2 days per week. Company holds a mandatory training, which employees could attend virtually or in person. Company representative selects a random sample of employees who attended a training in person and asks the following question: should the company return to an in-person work environment? After seeing the results, several employees argue the results of the sample should not be trusted because the results are biased. Which bias is present in the design of the survey? So go ahead and put which one you think is involved in this sample. All right. And then in this example, the answer is E, undercoverage bias, right? Because you're selecting out certain groups of people, right? And that's why the employees ended up, discussing that, arguing the results of the sample. So undercoverage bias. All right, when designing a sample survey, which of the following is the best way to reduce non-response bias? Make sure the sample size is very large. Again, no, remember sample size reduces variability, not bias. Make sure the sample is randomly selected. Okay, so sample is randomly selected. Again, they're saying non-response bias. So non-response bias is when you're leaving out or when people refuse to respond, right? They either can't be contacted or they refuse to respond, right? So ensuring that the sample is randomly selected is not necessarily going to remove non-response bias, right? Because this is a very specific type of bias. And same thing with sample size. Having a large amount may not reduce the systematic difference because there's people that are refusing to respond, for instance. Make sure there are multiple ways to contact and follow up with participants in the sample. Yes, this seems better because now, for example, if they refuse to answer the phone, then maybe you can go in person or email or whatever. So there's other ways that you can contact them. So follow up with work participants. Make sure there are multiple ways to contact them. That seems like the best way to avoid non-response bias. Make sure the survey includes many questions. No, this is going to have the opposite effect. It's going to increase the non-response bias. They're not going to want to fill out that survey. Avoid misleading or confusing questions. Again, avoiding misleading or confusing questions, that is a way to reduce the question wording bias and response bias and things like that. However, it's not going to deal with non-response. So it's got to be C. All right, guys. I hope you found this useful and informative as usual. I'll see you in the next one.